Day 3, Graphing Quadratics. How can you find the vertex of the graph of f of x is equal to ax squared plus bx plus c? So if we look at the core concept and we are graphing the function ax squared plus bx plus c, let's review a couple of the things that we looked at in previous sections. Recall, the graph opens up when a is greater than 0. So if we have a positive a value, our graph is going to open up. If we have a less than 0, so we have a negative a value, our graph is going to open down. The y-intercept is always the c when our quadratic equation is written in standard form. Some new things that we're going to look at in this unit is the x-coordinate of the vertex can always be found by using the formula negative b over 2a. So you're going to use the a and the b from the standard form of your quadratic to find the x-coordinate of the vertex. The x-coordinate of the vertex is the same as the axis of symmetry. So your vertex, when you have your vertex, your axis of symmetry is going to cut your quadratic function into two symmetric pieces, and it's going to be the line x is equal to negative b over 2a. So if we're given the function f of x is equal to 2x squared plus 8x minus 1, and they ask us to find the axis of symmetry, we want to use the equation from the previous slide. So x is equal to negative b over 2 times a. In your original function, you want to list what your a, your b, and your c terms are. So a in this function is equal to positive 2, and b in this function is equal to positive 8. So when we plug that into our formula, we get x is equal to negative 8 over 2 times 2. 2 times 2 is 4, so when we simplify negative 8 over 4, it reduces to x is equal to negative 2. So the axis of symmetry for this quadratic function is the line x is equal to negative 2. In order to find the vertex of the graph, the vertex is the point or the ordered pair x comma y, and the x is the same thing as the axis of symmetry. So half of our vertex we've already found. We just need to find the y. If we know an x value, we can input that into our original function and solve for our y. So we're going to plug negative 2 in for all of our x's. We're going to follow our order of operations, so exponents come first. Negative 2 times negative 2 is 4. Our next order of operations is multiplication in order from left to right, so 2 times 4 is 8. 8 times negative 2 is negative 16. When we combined our like terms, addition and subtraction is in order from left to right, so 8 minus 16 is negative 8. Minus 1 more, our y is equal to negative 9. So the coordinates of our vertex are negative 2, negative 9. The next example we want to look at says graph the function f of x is equal to 3x squared minus 6x plus 5. So you can see that they want us to state our axis of symmetry, our vertex, our y-intercept, and then they want us to describe the domain and range. So the first thing that we want to do is we want to list our a, our b, and our c, or label our a, our b, and our c. To find our axis of symmetry, we're going to use the equation negative b over 2 times a. So we're going to have a negative 6 over 2 times a positive 3. A negative times a negative becomes a positive 6. 2 times 3 is 6, and 6 over 6 reduces to 1 whole. Remember, your axis of symmetry is an equation. It is a line. In this case, it is the line x is equal to positive 1. So you can then draw that on your coordinate plane. The vertex, we have the x-coordinate of our vertex. We just need to substitute that x into our equation. So in this case, we're evaluating when x is 1. Follow your order of operations. 1 squared is 1, times 3 is 3, minus 6 plus 5. So the y-coordinate of our vertex is positive 2. You then want to plot 1, positive 2, for your vertex on your coordinate plane. What we previously learned is our y-intercept is equal to our c value. So we can see in our function above that our c value is 5. So when you write your y-intercept, you want to write it as an ordered pair, 0, 5. We can plot 0, 5 on our coordinate plane. Your axis of symmetry cuts your graph in half, so we can reflect that point 0, 5 across that axis of symmetry and then draw a smooth curve through the points that we plotted on our coordinate plane. We then, after have our graph on our paper, can state the domain and the range. So remember, our x values are going from negative infinity to positive infinity, so we say our domain is all real numbers. Our range, we want to look at what is that minimum value, or what is the y-coordinate of our vertex. So in this case, the y-coordinate of our vertex is 2, so we want all the values, or all the y values that are greater than or equal to 2 would satisfy our function. The next core concept that we want to look at is maximum and minimum values. The y-coordinate of the vertex of the graph of f of x is equal to ax squared plus bx plus c is the maximum value of the function when a is less than 0. So when you have a negative a, your graph is going to open down, which is a maximum. If you have a positive a value, your graph is going to open up, which is a minimum. So let's look at an example involving maximum and minimum. Given the function negative 4x squared minus 24x minus 9, can we look at our a, our b, and our c to determine whether this function has a minimum or a maximum value? So we notice that our a is negative. So a is less than 0, which is negative. And from the previous slide, we know that if a is negative and our parabola is opening down, we're going to have a maximum value. Then they asked us to find the value. So what are we finding when we find the maximum or the minimum? We are finding the y value of the vertex. So in order to find the x value of the vertex, which is the same as our axis of symmetry, we're going to use the equation negative b over 2 times a. When we plug in our b, we have a negative 24, so don't forget to write both of those negatives, and we have 2 times negative 4. Negative times a negative becomes a positive. Negative 4 times 2 is negative 8, and when we simplify this fraction, we get a negative 3. If the x value is negative 3, we can then evaluate our function when x is equal to negative 3 to determine our y. So we are going to plug in negative 3 for all of our x values and simplify. So make sure you follow your order of operations. Simplify your exponents first. So negative 3 times negative 3 is 9. Multiplication in order from left to right. So negative 4 minus 9 is negative 36. Plus 72 minus 19. And when we add from left to right, we are left with y is equal to 17. So we have a maximum at 17 when y is equal to 17. Then let's look at a real-world scenario problem where we would involve maximum or minimums. In example 4, it talks about the suspension cables between the two towers of the Mackinac Bridge in Michigan. And these two towers the cable between them form a parabola that is modeled by the equation y is equal to 0.000098x squared minus 0.37x plus 552, where x and y are measured in feet. So remember, it's important to label our answers, so we want to take note that this is measured in feet. What is the height of the cable above the water at its lowest point? So we are looking for what the height of this red cable is when it is at its lowest point or closest to the water. So we are looking for the vertex, more specifically, the y coordinate of our vertex is going to tell us what the minimum is. So in order to find our x coordinate, we need to use negative b over 2a. When we plug that in, we have a negative 0.37 over 2 times 0.000098. So you are using your a and your b from your quadratic. When we simplify that in our calculators, we get approximately 1,888. We then want to substitute that 1,188 back into our quadratic function and evaluate it for y. So you're going to want to use a calculator because these numbers are larger. You still need to follow your order of operations. So square 1,888 first, then multiply it by 0.000098. Subtract 0.37 times 1888, and then add 552. And when we do that, we get about 203. So when we are talking about how far our parabola is away from that water level, which is at 0, we can say it is about 203 feet above the water at the lowest point. You now should be able to complete and demonstrate your understanding. The online homework is 8.3. In the book, please do page 436, numbers 1, 2 through 28 even, and number 37.